Okay, so this is to help us with the bottom half of page 13 over here. And we have to be able to do distributive properties. So to help us understand that, I have a video about distributive law that we are going to watch.
Distributive law. First, try using order of operations to correctly evaluate this expression. 4 times 2 plus 5, where the 2 plus 5 is in parentheses.
Okay, so how would we solve this with order of operations? So for following order of operations, and we're following GEMDAS right here, what would we do first?
The group.
The group. Okay. So we're going to do 2 plus 5?
Yeah.
Okay. And 2 plus 5 is?
7.
7. And then we bring everything down. So it says 4 times. So it's not 4x. We're using it as times in this example. 4 times 7 is?
28.
28. Okay, so we'll type in 28, see what it says. Good work.
Right. First you add 2 and 5 to get 7, and then you multiply by 4 to get 28. Let's look at this expression using dots. First, you added 2 and 5, so here are 2 green dots and 5 purple dots. Then you multiplied by 4, meaning you have 4 groups of these dots. So the total number of dots here is 4 times 7, or 28. Now let's look at the green and purple dots separately. Here, we have 4 groups, each with 2 green dots. So we have 4 times 2 green dots. And over here, we have 4 groups, each with 5 purple dots. So we have 4 times 5 purple dots. That means the total number of dots here is 4 times 2 plus 4 times 5. And so we've just shown that 4 times 2 plus 5, where 2 plus 5 is in parentheses, is equal to 4 times 2 plus 4 times 5. These are 2 different ways of counting all the dots here.
So, are you guys following that? So we
Yeah.
can write this, okay, good. So we can write the problem 2 different ways. That's all he's explaining. You could write it with a group, or you could write it separately. Next.
Could count all the dots at once, or we could count the green dots and purple dots separately and then add them together. So looking at this equation, whenever you're adding 2 numbers in parentheses and you multiply that sum by another number, you can use the distributive law, which says you can distribute the outside number into the parentheses, multiplying it by each number inside. So we have 4 times 2, and we're adding that to 4 times 5. Let's try another example. Here's 3 times 6 plus 4, where 6 plus 4 is in parentheses. If we distribute the 3 into this sum, we have 3 times 6 plus 3 times 4. Try evaluating these 2 expressions to make sure they're equal.
Okay. So if I did 3 times 6, what would that be? Three times
18.
Okay. And then what is 3 times 4?
12.
Okay, so we simplify that to 18 plus 12. Now, what is 18 plus 12? If I have 18 over here, well, that's not going to work.
30.
Yeah. 30. Okay. So we're saying that answer is 30. And then Over here, you said 3 times 6 was 18. So that didn't change. And 3 times 4 is still 12. So it's still 18 plus 12, which will keep us with the answer of 30 again.
Nicely done. 6 plus 4 is 10, times 3 is 30. And down here, 3 times 6 is 18, 3 times 4 is 12, and 18 plus 12 equals 30. So these two expressions are equal, and it looks like the distributive law really works. Next, try using it on this expression, 8 times 9 plus 5, where 9 plus 5 is in parentheses. And remember that this dot is another way to write the multiplication symbol. Now this expression is equal to 8 times 9 plus 8 times another number. What's this missing number? Don't worry, this is not a trick question.
So what number are we going to put here?
5.
Exactly. Distributing 8 into 9 plus 5 gives us 8 times 9 plus 8 times 5. And you can double check to make sure these two expressions are equal. Now remember that when you're multiplying numbers, the order doesn't matter. So let's flip the order on the left side, giving us 9 plus 5 times 8. So even if the number you're multiplying by shows up after the sum in parentheses, you can still distribute. But in this case, we'll just draw the arrows going the other way. Next, let's see if distribution still works when we're subtracting numbers inside the parentheses. So let's look at 3 times 7 minus 2. 7 minus 2 is 5, times 3 is 15. So this expression equals 15. If we evaluate this with dots, we can start with 7 and then subtract 2. And then we have 3 groups of these dots. So the total number of remaining dots, after we removed these dots over here, is 3 times 5, or 15. But you can also think of this as starting with all 3 times 7 dots, and then removing, or subtracting, this group of 3 times 2 dots over here, again leaving us with the 3 times 5 green dots. So sure enough, 3 times 7 minus 2 equals 3 times 7 minus 3 times 2. So distribution also works with subtraction. When you're taking the difference inside parentheses and then multiplying by a number, you can distribute that number into the difference. Here's another example. 4 times 8 minus 3. Distributing, we get 4 times 8 minus 4 times 3. Evaluate these two expressions, and hopefully you'll get the same result for each one.
Okay, so I'm taking my 4 and I'm timesing it by 8. What number does that get me?
$32.
32. And then I'm taking 4 and I'm timesing it by 3. And 4 times 3 is 12. Okay. So I've simplified this answer. Right? Bring down my minus sign. What is 32 minus 12? And if that's difficult to solve this way, you can always stack them. 2 minus 2 is?
I got 20.
You got 20?
Yeah.
Okay. 0. 3 minus 1 is 2.
Yeah.
Okay. All right. Everybody got 20? 20. Oops, just saw the chest. Oh, sorry, Evelyn. Can you hear me better now? Okay. Have to remember to talk into the mic. Okay. So now if we solve it this way, 4 times 8 is still 32. Whoops, that looks terrible.
It looks like a Y.
Yeah, we'll pretend that says 32. All right, and then 4 times 3 is still 12. Bring down our minus sign. So we get the same problem, 32 minus 12. Is our answer going to remain the same?
Yes.
Yes.
Here are all my drawings.
Nicely done. 8 minus 3 is 5 times 4 is 20. And 4 times 8 is 32. 4 times 3 is 12. And 32 minus 12 equals 20. So the distributive law works on subtraction as well as addition. Next, let's distribute on to 3 terms inside parentheses. Here we have 5 times 6 plus 5 minus 2. If we distribute, we have 5 times 6, and then we're adding 5 times 5, and then notice that we're distributing onto subtraction over here, so we should subtract 5 times 2. Go ahead and evaluate these 2 expressions and make sure they give you the same result.
Okay. So the important part to remember is when we distribute, we have to distribute to every single unit in the group. So 6 times 5 is
30.
30. And make sure to bring down my plus sign in the same place. Now 5 times 5 is
25.
25. I bring down my minus sign in the exact same place. And then 5 times 2 is
10.
and then we simplify it because it's all addition and subtraction now from left to right.
Right.
So I have 30 plus 25. Always stack that. So 0 plus 5 is 5. 3 plus 2 is
5.
and now I have 55, but I have to minus 10. So 5 minus 0 is
5.
5. And 5 minus 1 is,
4.
so we get 45 for our final answer on the top. Now we're doing this again. So 5 times 6 is still 30. 5 times 5 is still 25. Bring down the minus. Notice how they're in the exact same order. 5 times 2 is still 10. So are we going to get the same answer?
Yes.
Yes, because it may look different, a little different, but as you can see, all our numbers are ending up the same. So we got 45 for our top and bottom.
Right, so in this top expression, 6 plus 5 is 11, and then subtracting 2 gives you 9. 5 times 9 equals 45. In the bottom expression, 5 times 6 equals 30, 5 times 5 equals 25, and 5 times 2 equals 10. 30 plus 25 is 55, and subtracting 10 gives you, once again, 45. So sure enough, these 2 expressions are equal. And to summarize, you can distribute multiplication onto both addition and subtraction inside parentheses.
All right. So what did you think about distributive law? Was it great, too easy, too hard, or confusing? Is it like a thumbs up or high five? Thumbs up. Oh, I see thumbs up. Okay. Let's see. So I'll just put great. Oh, here's someone. Thumbs up, good. All right, now that we did that, we're going to do it now with variables, okay? Because when we have all integers or numbers, I prefer to do order of operations and make the group smaller first. But the problem is when it's distributive property with a variable, we can't do x minus 2. So we must distribute first. 4 times 2, and then, or x, and then 4 times 2. So how I do that, when I do 4 times x, we write 4x. Okay, so we just put the number and the variable together because we don't know the quantity or the value of x, but we know it's 4 times whatever that number is going to be. Then I put my minus, and 4 times 2 is 8 equals 8. Now this looks like something I know how I'm more familiar or I'm more comfortable with. Okay? So now I have 4x minus 8 equals 8. Over here, for my reasons, because we distributed, we would write that. Okay. So first I had to distribute. That's the first thing I did. So what is the next thing going to be? If I'm going to get x all by itself, what do I need to do?
Instead of subtract, you have to add
Okay, so what am I adding?
plus 8.
Plus 8?
Yes.
Okay. Now I'm going to add 8 to both sides of the equation because property of equality means what I do to one side, I do to the other. Let's do that real quick. So now these ones cancel out. I rewrite my equation, and 8 plus 8 is
16.
16. Okay. I'm writing 4x equals 16. All right, so I have numbers on one side and the variables on the other. What is my next step? I did addition and subtraction, it's all done.
Multiply or divide.
Okay, so which one do I want to do?
Divide.
Divide.
Nice, yes, I am going to divide because it's 4 times x, and I need to do the inverse operation. I need to do the opposite. So what number am I going to divide by? The 4 or the 4?
4.
Yeah.
Very good. All right, so my 4's over here cancel out. And I'm left with 16 divided by 4.
It's 4.
Okay, so x is equal to 4. And then now we're over here to our reasons, and I told you guys when we distribute, we can draw our arrows over here, and we can write the word distribute. So what else am I writing after that?
DPOE.
Okay, did I do DPOE first, or did I do a different one first?
SPOE.
S. I mean,
Yeah, APOE.
Yeah, nice. Because over here in the orange, we added. Yeah, it said subtract, but we added it. So APOE and then DPOE. That's what I'm hearing. And now we go over to check our work. So this is one extra step that we weren't familiar with, but we're getting a lot more comfortable with doing these steps. Okay, check my work. When I check my work, I am plugging in the value I got, which is 4. So I have 4 times 4 minus 2 equals 8. And now that I did that, we can distribute again, but that gives us a lot of bigger numbers. If we can, so we can either distribute 4 times 4 and 4 times 2, or we can say solve for the group, simplify the group first, 4 minus 2. So which one would you guys rather do?
You what?
Would you rather distribute like this with the arrows, or do you want to make this group smaller first?
Distribute.
Okay, we can practice with distributing, and I'll do it. Actually, what I'll do is I'll do this both ways. Copy. And I'll do it in a different color. Oh, why is it not working? Uh-oh. Okay, let me pause my recording.
Nope.
Okay, so we're gonna start with the distribution side, how we distribute it, and then we can also do the order of operations way. Okay, so first we're gonna distribute. Another color here. So I'm gonna do 4 times 4, and then 4 times 2. So 4 times 4 is
16.
15. Okay. And then 4 times 2 is
8.
8 equals 8. And now 16 minus 8 is
8.
8. Oops. Equal
To
2.
8.
All right, does that check out?
Yep.
Nice. Okay.
Check mark and put true.
Yeah, okay. We'll put true. Now we'll solve it where we do the group first, okay? So 4 minus 2 is
2.
2.
another color, purple. So I have 4 times 2, because 4 minus 2 is 2, equals 8. And then 4 times 2 is
8.
8.
8 is equal to 8. So does that check out?
Yes, still true.
All right, still true, no matter which way I solved it.
You still get the right answer.
That's right, they are both correct. So whichever way is more comfortable for you, okay, whichever one you like better. So how many people like this way better with distributing, where you have to times it and then minus it? Anyone like this way better?
Yeah.
Yeah, you like that one? Okay. Does anyone prefer this way? Where we go through order of operations? No comment. Okay. So a couple of us like it this way. It might be easier because we had to distribute, so we distribute again. Yeah, so Evelyn, you like this way better? Okay. So for some people, doing the same process of distributing is easier. Other people says, okay, I'll do this, but because I have to, but I prefer to do it this way when I can. Okay. So we'll do another one. And I think for this activity, we'll solve it both ways so we can see it. But no matter what, we get the same answer. Okay. Method 2, division property of equality. So that one was with adding. Was it with adding? No, it's not. Oh, distributive property division property. Oh, I see. And now I gotta teach you this way. Okay. So that was distributive property, and then division property of equality is another way we can solve this, which I will show you. So division property of equality, that means, how do we write division property of equality?
DPOE.
Yeah, DPOE. Okay, so now I'm going to show us how we can use DPOE to do this. Okay? This is actually my preferred method. Okay? I like this one better because this says 4 times the group, correct?
Yes.
So
Yes.
because we're timesing the whole group, and let me make sure I write this here from an example. And we get AS MD G, we're undoing the operation. So because this is a group, it's at the bottom. So even though this says minus, it's inside a group. Okay, so I can start with multiplying or dividing. So 4 times the group, I'm going to divide the whole group by 4, okay? And the 8. So when I am dividing it by 4, what happens to the 4s on this side?
It cancel out.
Yeah, they cancel out. They are gone. And then I have 8 divided by 4. Can I divide 8 by 4?
Yeah, it's 2.
It's 2. Okay. So now that I got rid of that, oops, I'm going to do x minus 2 equals 2. So I simplified my equation. Okay. Now it says x minus 2. What do I need to do?
Add.
Yeah, I'm going to add 2. Just 2. Okay. So now I'm adding 2 to both sides. So adding 2, -2 plus 2 is 0. They cancel out. And 2 plus 2 is
4.
4. So now x is equal to 4. So did we get the same answer? Because this is the same problem, we just solved it another way. Did we still have x is equal to 4 on both of them?
Yes.
Yes. Okay. Okay. So my reasons, what did we do first this time?
Divide.
The, yeah.
Okay. So we did depot. And then what did we do after that?
APO.
APOE. So when we did that, it was less steps, correct?
Yep.
So this is kind of a shortcut. So you have the regular way and then you have the shortcut way. Does anyone like the shortcut way better?
Yeah.
Yeah.
Yeah, maybe? Okay. So did both methods work?
Yes.
Yes. Okay, and how do you know that?
Because they got the same answer, right?
Because I got the same answer. Yeah, so it's an agreement. And then here is where you write which method you prefer, okay? So either you're gonna write you like depot or you can write distributive property. Which way do you like better and why? I typically would go with the one that is easier for me to understand. Because to do distributive property, we had to go review it and it had to teach us how to do it. This one, DPOE, is something we already knew how to do. But it's up to you, because a couple of us said, yeah, we like distributive property easier. So does anyone want to share what they wrote down? Options in here, depot or okay. You like the distribute one better, Ethan? Okay. Okay, so yeah, you just put which one and then a sentence about why. Yeah, okay, cool. Yeah, if you like that one better, you can do that one better. Okay. Now that we have 2 ways to solve it, it says here's some tougher problems on page 14. So we'll just do this first one and then we'll be done, okay?
Okay.
All right.
Okay.
So I heard 3 people for distribute out of 4 people. That's 75% of the class. So I'm going to use the distribute method for this. Is that what I'm hearing? Okay. And it's a reminder to use pencil. Okay.
No pen.
No pun. All right. So Jolene, Claudia, and Ethan also that they prefer the distribute method. Is that correct?
Yes.
Okay.
Yes.
So we're gonna solve it using that way. If you're watching this video and you liked the shortcut way, then absolutely use your work during the do your work with the shortcut way. That's so good. All right. All right. Two. Okay, so I'm gonna draw my arrows from 3 times x and then 3 times 2. Okay. So how am I going to write that? Three times x is if I do the 3 times x like this with the arrow, how do I write that? 3x?
Yeah.
Okay, so we just write 3x. And then 3 times 2 is?
6.
Okay, equals? All right, now what do I do next?
Do the order operations backwards.
Okay, order of operations backwards. So I'm going to start with
Plus 6 is minus 6.
okay, so I'm going to do minus 6 on both sides. Six minus 6 is 0. So now I rewrite my equation. 3x, 10 minus 6 is
4.
so now I have 3x equals 4. What do I do next?
Divide.
Divide both sides by what number?
3.
All right, these 3's cancel out. They make the one big factor. And then can I divide 4 by 3 or is that all done?
You can divide by 4 times 3.
You can? What is it?
You can't.
Oh, you can't. Sorry. Okay. So I'm going to keep this as 4/3 because it's as small as it gets. Okay. And what do I write for my reasons over here? What did I do first?
SPOE.
Okay, but before that, what is this called with these arrows? And then we had to rewrite the problem.
Distribute.
Yeah, so first we distributed. You could write DIST for like a shortcut. Okay. And then you subtracted?
Yeah.
Okay. Then we did SPOE. And did we do anything after that?
DPOE.
DPOE. Okay. And then we simplified. Okay. So now I have to rewrite my problem equation. I have 3 times 4/3 plus 2 equals 10. Okay, and then put my 3 under here. My fraction line. Okay. And then what I can do is I could put a 1 under here. Okay, like a line and a 1 to make it easier.
Yep.
Okay. And then, oh, and we could put a 1 under this 3 if we want. Okay. So I have a fraction times a whole number and a group. Okay, so do you want to distribute? That's kind of complicated, huh? Let me show you guys something. I feel like I made a mistake. Let me pause this real quick. Okay. So if we're timesing those across, 1 times 3 is 3, 1 times 1 is 1. Okay. So then we multiply, we distribute the top. Let me make that another color. So we do 3 times 4, 3 times 2, and we put our 1s here for a visual. We still, even though it's on the bottom, we can still multiply them like that. Okay. Write that in purple. So if we're looking at it that way, which is a bit sloppy looking, apologies. 3 times 4 is
12.
12, and then 3 times 2 is
6.
6.
Okay. And then I still have a fraction line. So 1 times 3 is
3.
3. And then 1 times 1 is
1.
1. Okay. Then we'll put our fraction lines back in here. Okay. So can I divide 12 by 3?
Yes. Oh, wait, no.
Yes.
Yes, what is it?
4.
I mean, 4, yeah. Sorry.
So 3 goes into 12 4 times.
Yes.
All right. Oops. So we got 4. And 6 divided by 1 is
6.
6. Equals 10. All right, let's make sure I put that over here too. Equals 10. Okay. And then 4 plus 6 is
10.
10 equals 10. All right. So does this check out?
Yes. True.
True. Was it confusing with the fraction?
Yep.
Yeah, you know what? Even I had to think about it for a minute. I was like, wait, give me a second. Okay. I wanted to make sure did I explain it okay, or did I explain it too confusing?
Explaining okay.
Okay,
Yeah. Okay.
good. I was like, oh no, I hope I don't say this in a confusing way. I had to gather my thoughts for a second. Okay, so true. All right, do I need to do anything else for this problem?
No.
No? Good. Okay, and then on Friday we can pick a Kahoot to do. Does that sound good?
Yep.
Yes.
Okay, and that's all we're gonna do for today. So let me stop this recording.